Hello everyone. Today's problem is figure shows a pictorial view of an object by using first angle method of projection. Draw sectional front view along sectional plane AA. Right hand side view, top view, and you have to give dimensions. Now in this case you have to draw sectional front view. So first of all we'll see what is sectional front view. Let's see the one example. Suppose there is one cylinder. This is a solid cylinder, let's say. Okay, if I cut this cylinder, like through this AA plane, means I'm cutting this object from this plane, right? Then how it will look? Let's draw its front view. If I draw its front view, then how the cylinder will look? See, this is the front view of an object, right? For in a normal case, right? If this is a normal front view, then its front view of cylinder is looks like this. But this is a sectional front view, in which case we cut this object from this AA plane. In that case, this whole surface cuts by this AA plane, right? This whole surface cuts by this AA plane, so that you have to show here a hatching lines. You have to show here a hatching lines. Then this is the sectional view of this cylinder. This is solid cylinder. If I took a example of hollow cylinder, if this is an hollow cylinder, and if I cut this hollow cylinder through this AA plane like this, then how to draw its sectional front view? First we'll draw its normal front view. Its normal front view looks like this, and we are looking from this side, so this inner hole, right, looks like it is invisible to you from front side, so you have to show that inner hole by dotted line, right? So this is its normal front view. But if you want to draw its sectional front view, then we cut this cylinder at this plane, right? And after that, which surface is cut by this plane? Yes, this surface and this surface, right? So in a sectional view, right, there is no need to show the dotted lines, hidden lines, because when you cut this object at this AA plane, right, this edge and this edge will visible to you. So I'll make that dashed line as a dark line, right? And then which surface is cut by this plane? Yes, this surface and this surface. So I show that surfaces with a hatching line. Now why I'm not drawing the hatching line here? Because see, this is the hollow part. Here there is a no material, right? At this plane here there is a no material, means there is no surface, right? So that we show hatching line only here. Clear everyone? So this is sectional view. This is full sectional view. There is a half sectional view also, in which we cut the plane, we cut the object like this. right? So we remove this 1/4 portion of object and then we draw its front view or any view. So likewise we can draw half sectional view also. You have only full sectional view. Okay, so we'll learn that full sectional view. Now we'll start our problem. Okay, remember this, wherever we cut the surfaces, there only you have to draw this hatching line. Clear? Here there is a hollow part, means no material, so we are not drawing here a hatching lines. Okay, so now we'll start our problem. Okay. Okay, so this is the object and you have to draw front view, the sectional front view in this direction, right? And you have to draw right hand side view, top view, and you have to give dimension. See, the marks distribution is like this in any problem. There are 5 marks for front view, 5 marks for side view, 5 marks for top view, and 1 mark is for dimensions. For every problem the marks distribution is like this. So if you complete one view only due to the time limit, then also you will get a marks. So the marks distribution is like 5 marks, 5 marks, 5 marks, and 1 marks for the dimension. Clear everyone? Now we'll start the front view. First we'll mark the overall dimension of an object in a front view, top view, and side view. Now we'll fix the position of an front view. So here we'll draw the front view. At the left side of a front view we'll draw right hand side view, and here we'll draw the top view, right? Here front view and here top view and here right hand side view. Clear? So now we'll fix the overall dimension. So this is a x direction. See, in some cases they show this y direction also, but remember this, in a x direction you have to draw front view and in a y direction you have to draw side view. Okay, so in x direction you have to draw front view. So its overall dimension is 100 by this total height, right? So the total, let's calculate its total height, right? 6, this gap is 6, or this total height is 18. We have this 18 dimension, right? 18 plus this 22. So 18 plus 22, right? 18 plus this height is 22, and yes, this height is equal to radius of this half circle, right? This height equal to this radius of this half circle. This radius is 22. So the total height is 62 and the length is 100, correct? So we'll mark the dimensions. So 100, then height is 62. Correct. Now we'll mark overall dimension of top view. So which two dimensions are visible from the top side? This 100 and 40. Right, 100 mm length we have only in already in a front view. So we'll project it down. So here this is 100 and yes 44. So 44 mark here. Okay, 144, 144. Okay, and then in a side view, right, in a right hand side view, which two dimensions are visible? Yes, 44 and height. So height, that is a 62, and 44 we have in a, yes, in a top view. So from intersection point of xy line and x1 y1 line, we'll draw line inclined at a 45 degree so that we can project right this dimension in a side view, right. Okay, so we'll get this 44 mm in a side view and we'll project this height, right, 44, and this is 62. So we'll project that 62 mm distance in a side view, right. So now we'll get the overall dimension of an object. Clear. Now we'll start our front view. We have to draw sectional front view along sectional plane AA. So now see, this is a AA plane, right. This is a AA plane. So we cut the object the middle, right. So first, before drawing the sectional front, we will draw normal front. Okay. So let's draw it. So from this side, this surface, right, this surface is visible. So let's draw it. So the total length is 100. So this is 100. Then this and this distance is 12. So mark 12 mm, 12 mm from both sides, right. This distance is 6 mm. So 6 mm, 6 mm from both sides, and then draw horizontal line. Then this height is 18 mm. So 18 mm, mark here 18 mm. Clear. Now this portion, right, this portion is at the middle of this 100 mm distance. So we will mark here the center. So this is 100 and I'll mark this center line at the middle of this 100 mm distance. So from this center line, okay, I'll draw this line first. Okay, so 6 mm this side, 6 mm this side, because this is a 12 mm which is middle of this 100 mm distance. So I'll mark 6 mm this side, 6 mm this side, so that I can draw this line, right. Okay, now this is a front view. When I look this object from front side, this curved surface, right, this curved surface appears as a straight surface, plane surface, right. Only that curved surface appears in a side view, right hand side view, right. From front side it appears straight or plane. Okay, so it looks like this, so like this. Okay, so we'll draw that rectangular portion here. So its height is 22 plus the radius of this half circle. So 22 plus 22, 44. So from here we'll mark that 44 mm distance. Right, that curved surface is not appears in this from this side, right. It appears like a straight surface or plane surface. Clear. So this is the visible portion of this object. Now we'll mark the invisible portion of an object. So which surfaces or which portion of an object is not visible in this problem? See, this holes, right, these two holes are not visible from this side, as well as this hole is also not visible from front side. So we'll draw dotted line for it. So first we'll locate the center of these two